Hello friends, good morning. Welcome to Relief Tutorials. Let us start with the chapter number 12, Physics, Sound. See, in our regular life we hear many types of sounds from morning to evening. Sound of birds, vehicles. In TV also we hear sound. In normal conversation with our friends and our family members, we hear sound. Suppose you are in a classroom and you are with your friends. You are sitting on the first bench. Your friend may be sitting on the third or the fourth bench. You are speaking from the first bench and he or she can hear your sound at the fourth or the fifth bench. So the question is that how the sound is produced. Many questions arises during this whole process of producing sound, means how the person can speak, how the sound can be produced. For example, if I tap like this, if I tap here, if I clap, number of ways we can produce sound. So what is the reason behind producing the sound? So in this chapter we are going to cover some questions. First of all, how the sound is produced. The first question is how the sound is produced. Second question, once the sound is produced. For example, I am speaking, so I am the producer of sound. Anyhow, the sound is produced. But now the question is how it reached to yourself or on this side or in any direction. So second question is how the sound travel. In place of travel, you can use the word propagate. How the sound propagate. Propagate means travel from one place to another. How the sound is produced. Once the sound is produced, how it propagates in any one of the direction. As we are discussing that you are on the first bench. You are speaking something, so you are the sound producer. Your friend is on third or the fourth bench. So how the sound reached to that point? What physical characteristics helps sounds to reach any one of the place? And once the sound reach at that place, how your friend is able to hear your sound? What characteristic is present in that person which makes her he or her able to hear the sound? So how the sound can be heard? How I can hear such sound? How you are able to hear many sounds in your surrounding? These are some questions regarding sound, and these we are going to cover in this chapter. But before that, let us take the introduction of sound. What exactly the sound is? What exactly the sound is? So let me tell you, sound is a wave. Sound is a wave. So here the question arises, what do you mean by wave? We are going to cover these questions but later on. First of all, let us take the introduction of wave. What do you mean by the word wave? See, I know that whenever we speak the word wave, one picture came into your mind, and that is like this. Right now when you are hearing this lecture, when I speak the word wave, the sound is a wave. So I think suddenly the picture came into your mind is this one, that this is called as wave. Wave in the ocean and the sea. See here, this is not exactly the wave is. In terms of physics, what do you mean by wave? So to get the answer of this wave, first of all, let us take the introduction of some technical words. The first one is periodic motion. See, we are heading towards the meaning of wave, but before that, some words should be very clear. First, what do you mean by periodic motion of a particle? Means of any of the thing. What do you mean by periodic motion? Periodic motion means if a particle if a particle repeats its motion, if a particle repeats its motion, the particle should repeat its motion again and again. See here, what do you mean by the word particle? Generally, most of you having the meaning that particle means a small size substance. No. In physics, particle means any of the substance, living, non-living, small, big, far, near, whatever. I myself can be considered as a particle. You are also one of the particle. So in physics, every substance is given a common name is particle. Even the planet Earth is also called as one type of particle. Even the sun is considered as a particle. So if a particle repeats its motion on a fixed path, not only repeating should be also on the fixed path, about a fixed point, means around some particular fixed point, considering one of the point as a reference and revolving around it or going up and down around one of the point. We are going to take some examples. If a particle repeats its motion on a fixed path, the path should not be changed about a fixed point. So about one of the point, and that point should be remain fixed after regular time interval. So if a particle performing such after regular time interval, means after say the speed of moving, here is one of the particle is moving repeatedly on a fixed path about a fixed point after a regular interval of time. If you take the example, best example, that Earth revolves around Sun. Not only Earth, each planet revolves around the Sun. So if you consider, let us check the motion of Earth. Answer yourself. Earth is repeating its motion or not? Yes. On a fixed path, we know that here is Sun and the Earth is revolving in such type of path. What do you think? Earth changes its path after every revolution? No. So the path is fixed? Yes. Repeating motion? Yes. About a fixed point. Here Sun is a fixed point for Earth. About a fixed point means around Sun the Earth is continuously revolving. What do you think? After every revolution Earth changes its point? No. So here Earth is moving around a fixed point called Sun after after regular interval of time. Is true. For example, one first revolution completed in 365 days. We know it. So what do you think? The second revolution is somewhat faster or slower? No. So Earth repeats its motion on a fixed path about a fixed point after regular interval of time. So this type of motion is called as periodic motion. So we can say that each planet, including Earth, is performing periodic motion. Let us have some examples. First example, planets revolving around Sun. First example for periodic motion. What is the definition for periodic motion? If a particle repeats its motion on a fixed path about a fixed point after regular interval of time, then such motion is called periodic motion. Okay, now further, one more example. Let us say swing. Here is the swing. So right now the swing is not in motion. So this is the fixed point where the swing is stationary, steady, not moving. Now when someone starts to swing, I think the motion of swing will be like this. So this is a fixed point about which the swing is moving. From fixed point in one direction, again to the fixed point, another direction, fixed point. So about this one of the fixed point, it is continuously moving. For your information, this fixed point is also called as mean position. Is called as what? Mean position or original position. Also called as original position. Okay, so it repeats its motion? Yes. About a fixed on a fixed path? Yes. About a fixed point? Yes. After regular interval time? Yes. So all the conditions satisfied here. So swing is also one of the example for periodic motion. One more example, you can take pendulum. Pendulum. Very simple example. Consider right now the pendulum is not working, not moving. So this is the fixed point. When it starts moving, I think it again moves like the swing only. Pendulum, I think we have seen the pendulum, it moves like this. So what happens, the fixed point is here, it goes in one of the side, again a fixed point, another side. So it continuously repeats its motion on a fixed path, about a fixed point, after regular interval of time. So I think this type of motion is also called as periodic motion. One more example we can say, many examples such are there. Seesaw, we can take the example, and most technical example is vibration of atoms or molecules in matter. If I take the example like this, consider this is one of the solid piece. We know the solid piece or any of the solid, liquid or the gases, every matter is made up of its particles, small sized particles. Normally these small sized particles are called as atoms or its molecules. So consider these are the particles. Let me draw it somewhat bigger. There are some particles of matter. Now what do you think? These particles are stationary inside the matter? They are steady, fixed at one of the position? No. Based on the temperature in their surrounding. Based on the temperature in its surrounding, each and every particle possesses some amount of energy. And due to presence of this energy, these molecules are having the continuous vibration. Up and down or to and fro, back and forth, whatever the path you can say. So these molecules are having the continuous, consider this is the position of particle. Assume that it is stationary right now. So it is the original position or the fixed point, we say mean position. Now it moves right hand side, come back to original position, left hand side, and this way continuously having the number of vibration it performs in 1 or 2 seconds. So it continuously having the vibration. This is also one type of periodic motion, because repeating motion, yes. Fixed path, yes. About a fixed point, is a fixed point, yes. After regular interval of time, it's yes. So it means that these are some examples of what? Periodic motion. What is the path of this planet? Circular. Path of swing and pendulum is curved. Seesaw, I think also having the curved path. Seesaw, I think you have seen, you have played many times. Okay, so now it goes up and down, up and down. So it's having the almost a curved path there. So seesaw, swing, the pendulum having the curved path. Planets are having the circular path. Take note. Planets are having what? Circular path. I am writing the type of shape of the path. Swing and pendulum are having the curved path. Seesaw also having the curved path. And what about the vibration of atoms or molecules? So vibration of atoms or molecules are having this type. They are going left and right or up and down, but it's not curved, it's a straight one. So the path here is straight path. Okay. One more type of motion, filtering out the different types of path. Based on the types of path, we have some two more types of motion. One is oscillatory motion. Oscillatory motion is also called as oscillation. Now oscillation, all the conditions are same as that of the periodic motion. What was the definition? That if a particle repeats its motion. So in this oscillatory motion also conditions are, first of all, particle should repeat its motion just like the periodic motion on a fixed path, but here the path should be except circular path. Only that type of periodic motion which is having a circular path is not included in oscillatory motion. So if the path is except circular path, means which type of path are included? Means circular path is not included. So the path should be curved to and fro, up or down, or straight path. So these paths are included and circular path is not included in oscillatory motion. Other conditions are same as that of the periodic motion. So repeats its motion except on the circular path about a fixed point. About a fixed point. We know that fixed point is also called as mean position. And after regular time interval, or other conditions are same as that. Now if you see, what is the difference in this periodic motion and oscillatory motion? In periodic motion all the paths are included, but in the oscillatory motion only this path will not be. So this is not called as oscillatory motion. This is periodic motion, but it is not oscillatory motion. These all having the curved path or straight path, so they are included in oscillatory motion. They are already periodic motion. But now they are also called as oscillatory motion. And one more type is called as simple harmonic motion. Simple harmonic motion is shortly called as SHM. In this simple harmonic motion, all the conditions are same. Repeating its motion, yes, about a fixed point, regular interval of time. But which paths are included in this? The only straight path. If the particle repeating its motion on a straight path about a fixed point after regular interval of time, then only that type of motion is called a simple harmonic motion. So out of these four examples, only the last example is called as simple harmonic motion. So based on the different type of path, we have two different category of periodic motion, oscillatory motion and simple harmonic motion. So in the simple harmonic motion, only one example is here. We can take many other examples, but right now out of these four, only one example is able to set in the simple harmonic type of motion. Okay. Now, consider here is water, and these are the molecules of water. See, water is a liquid state, and we know that in the liquid state the particles are slightly away from each other, not like solids that they are consisted or they are very close to each other. This space is called as intermolecular space. I think you know that, and there is some force of attraction exists between each and every particle, and that force is called as intermolecular force of attraction. These are all the things you have learned in the lower standards. So here, consider these are the particles of water. There exists intermolecular force between them. There is attractive force, and there is certain space between them. Now, let me throw one stone on this water. And see, number of times we have seen this. If you have a small pond in front of you and you are throwing one of the stone, you will see water ripples are formed. Water ripples are formed, and normally we call them as the water waves. But what exactly the science behind this? Let us see. I am throwing a stone here on this molecule of water. Means I have thrown the stone on this molecule, means I am transferring the energy to this particular molecules, some molecules of the water. Let us say this is the molecule which is hit by the stone and gathered the energy, and this molecule which was considered to be stationary right now, when it is hit by the stone, it get the energy from the stone and it is disturbed. For example, this molecule is disturbed and going down. The stone pushes this molecule of water, so this molecule is going down. But we know that there is a force of attraction. There is a force of attraction to the molecules, between the molecules, and that is called as intermolecular force. Now this molecule is disturbed, not this one and not this one also. So this molecule is disturbed, so it is going down. But these molecules, means the neighborhood molecules, are stopping this molecule to go down further. That's why what happens, that this molecule is going down. So what do you think? This molecule is down means what? It goes to the bottom? No, it is not going to go like this. This molecule is going down, so along with that, because of the force of attraction, this molecule also drags downwards. Okay, are you getting this? For example, you and your friends, 4 or 5 different friends are holding the hands with each other. Now, can any one of them go forward or backward? If one of them is trying to go forward, other also drag along with the first person. Same way, this molecule is getting the energy from the external source. Okay, so now this molecule is going down, but due to force of attraction, this molecule also drags behind it. When this molecule also comes along with the first molecule, not exactly the same way, but some time afterwards. So this molecule reach up to this point, for example. So at that time, this molecule may be reach here only because of the force. So now this molecule is here, this molecule is here, but due to that, but there is a force between this and this molecule also. So this molecule also drags along with the second. So first molecule is disturbed. That is why the second also getting the disturbance. That is why the third also getting the disturbance. That is why the fourth also getting the disturbance, and so on. The disturbance passes. What passes? Disturbance passes. Molecules are not passing. Molecules are not moving. What do you think? When you hit the stone on this molecule of water, this molecule starts moving in any one of the direction? No. This molecule is only getting some downward drag in one of the direction. Let us say it's going down up to this point. Not more than that. But due to this, what happens? Due to intermolecular force present between the molecules, the disturbance passes from one point to another. So these phenomena, motion, something is moving here. Ask yourself, what is moving here? Is this particle is moving? No. This particle is moving? No. It's not going from one place to another. Not that type of motion they are performing. But one thing is moving, and that is moving what? The disturbance is moving. The first molecule is disturbed, so the second one, so the third one, so the fourth one, so something is moving, and that is the disturbance. And that is called as wave. Motion of disturbance is called as wave. So what do you mean by wave? Wave is one of the phenomena. It is not the physical thing. It's not the thing that I can hold it or I can transfer, I can give you or you can give me. Wave is one of the phenomena. It's one of the incident in which the disturbance is moving from one particle to another. Particles are not moving. Disturbance is moving from one particle to another. It is like that. For example, 10 to 15 cycles are parked in the line. If I keep the first one, if I keep the first cycle, second also falls, third also falls, fourth and the 10th also maybe fall. Now I am not disturbing the 10th one. I am disturbing the first one. I have disturbed the first cycle, but the energy means the disturbance transfers from first to second, second to third. So what is moving? Disturbance is moving, energy is moving. So motion of disturbance, or you can say motion of energy, is called as wave. Now if you see the broad picture of transfer of energy in this water, that consider these are the molecules. Okay, this first molecule is getting the disturbance from external source. Let us say it starts to go downward. Let us say it reached to this point. Okay, so at that time on the second particle is on the verge of going down due to the drag force, due to the intermolecular force. Okay, then it goes up to this one, the maximum downward displacement of this particle. So let's say it moves up to this one. So at that time the second molecule maybe reach up to this point. So the third molecule is on the verge of starting the motion. This molecule is not going to go further downwards, it again moves in the upward direction. So this molecule goes upward again up to this point. Okay, I am drawing the present situation only. And this molecule goes here like this. It reaches up to the maximum downward displacement. And third one is, let us say, reach here, and fourth on the verge of starting the motion. So gradually the disturbance passes. Now this molecule again come to the original position. This is the original position of the molecule. It has completed the downward and further upward motion. Now when these molecules reach here, this molecule maybe again coming upward and reach up to this point. This molecule comes to the extreme downward position. This molecule already started the motion. It comes here, and now this molecule is on the verge of starting the motion. Now this molecule, it has completed the downward motion. It again comes to the original position. Now again goes to the upward motion, upward side. It's like a vibration. Original position was here, goes downward again to the original position and goes upward. It's like what? The up-down vibration. It goes upwards. At that time, these molecules reach the original position. This molecule may be halfway up, and this molecule extreme down. This is halfway down, and now this molecule on the verge of starting the motion. Now this molecule reaches the maximum upward displacement. This is halfway up now. This is at the mean position now. This is halfway up, maximum down, halfway down, and now this molecule on the verge of starting the motion. Now again this molecule from extreme up start to go downwards again to the original one. So it again comes to here, maybe extreme up. This is halfway up. This is at the mean position. This is halfway up, extreme down, and halfway down, and this molecule on the verge of starting the motion. Now this molecule again comes to the original one. So it has completed one complete. I think you see that this molecule has started the motion to go like this, and again come to the original one, and then again go upward and come back to this. So this is one complete oscillation. So this molecule has reached again here. This molecule halfway down. This was going upwards. So I think it's a maximum upward. This was at mean. So halfway up. This was here. So it reached to the mean position. This was extreme down. It starts to go upward. This was halfway down. So it goes to the maximum down. This was halfway down, and now this molecule on the verge of starting the motion. So if you see carefully that this molecule has completed one oscillation. One oscillation means one complete path is covered. One swing one oscillation of pendulum, one vibration of molecule. What do you mean by one vibration? How it completes one vibration? This is its mean position. It goes right side, goes to mean, then left side, and then comes to mean. This is called as its one oscillation. If you think about the upward motion, it goes to up, then mean, then down, and then mean. It's called as one oscillation. So here also this molecule has started its motion by going downwards, then mean, and then upwards, and then mean. So one oscillation is completed. Now let us see the position, the real present position of all the particles. So this is here. Now this molecule is actually here. So this is not there. It is here now. This is here now. This is original only, not here. So these are the original positions of all the particles. And if you join them, it seems like what? The wave. And this is why we see the water ripples. Remember, when you throw a stone in water, you disturb one or two particles of water, but those particles are not moving from one place to another. They are just doing what? The vibration, up and down motion only they are performing. They are not moving. It seems, when we observe, it seems that the water is coming towards you, but actually the particles are transferring the energy from one molecule to another. So due to the transfer of energy, they reach to your place. So in today's lecture, we have just taken the introduction that what is wave. We have seen the definition of periodic motion, oscillatory motion, simple harmonic motion, as well as wave. Definition of wave is simple one, motion of disturbance. So students, make the notes regularly, repeatedly watch this video. Okay, subscribe and like our YouTube channel, and please prefer the notes.